Good evening, folks. So we today will be looking at this topic where we'll be looking at how GitHub is something that can be targeted and how it is attacked and how can we defend against it. Trying to keep it somewhere in between technical and non-technical. So yeah, we'll just. I think we did get an introduction, so I'll skip this. Uh, so we'll be talking about GitHub Actions, the threat and attack vectors that we can see in GitHub. Then a bit about workflows, actions, apps, common misconfigurations, and we'll look at key takeaways. So to start with, what is GitHub Actions? We'll just get a gist of what it is, what it does. So basically, it's automation flow that you get with GitHub, where you can write your workflows and automate whole of your actions. So that is basically where you use in your CI/CD pipelines. So a bit about what workflows are. This is something that will help you write your actions. Basically this is the flow that you write and it executes. So again, the workflow code is something that is stored in your repository, and since it is also in your repository, it will also have access to your secrets. And this is a very simple example of how a workflow file looks like. So we'll talk a little bit about what workflow does, right? So basically, it's something where it helps you write some sort of automations where you can configure it to do something like let's say, for example, you want to build your code base. You write a workflow for that. You want to push it to your let's say Docker Hub. You can write that. You can build an image. Some few examples that you can see of how a workflow can be used. There's a lot more that that can be done. We'll talk a little bit about attacking GitHub workflows. What exactly happens. So this is one concept of workflow injection. So workflows are something that is meant to be run in your own repository in a controlled way. Basically, who are the owners or people who have access to the repositories can make changes and execute it. But it can be configured in a lot of ways since it is used for automation. So there's a lot of configuration that can be done. So one of the things is when workflows are used. So this is what a workflow looks like, where basically there'll be a trigger that can be set where a workflow can be triggered or it can be initiated, and there are a few steps that that can be written. That's something that is part of the jobs that you can just have a look at it here, and it performs some sort of action. So these are few contexts that GitHub gives where you can make use of these things. Consider these as the variables that you see in your Linux, where something like issue title, issue body will have let's say when someone creates an issue in GitHub, this is something that will give us, or we can extract the title of that issue using these contexts. And maybe we'll consider a quick thing about workflow injections here. So just to understand, I'll give a bit of context here. This particular workflow, what we are seeing here, it's basically it's trying to it's basically triggers whenever a new issue is created in your GitHub, and it's printing whatever is the issue title is. And if you look at the highlighted bit, so that's basically where we are just printing whatever the title is. So this is expected to be run in, again, like I was mentioning, in a controlled environment where let's say someone where you have a repository where people can add their own or create issues. Whenever, let's say, someone sees a problem, they can create an issue. What this does is whenever an issue is created, it basically runs this or triggers this, and it prints whatever the issue title is. I mean, just a sample example. And again, we are assuming that in this case, the issue title is something that is trusted, which is not really. So that is what we see. What if the issue title is something like this? This is a valid issue title that can be used. If we maybe observe it a little bit, it's basically a Linux command that that is being passed, where ls is listing command that can be used, where it lists all the directories and files that are present. So this is exactly what happens when let's say someone adds a issue title, something like what we saw here, instead of actually giving a valid issue name. So it basically executes the command that is being given. So here, this is an insecure command that is being passed, where let's say this is the classic example of command injection, right? So this is something called workflow injection, where let's say this is something that is used in a public repository, where some user can create an issue. This triggers, and they get a command injection vulnerability where you can execute commands into runners that are used in GitHub. So moving on, we'll have a look at another maybe not so common, but yeah, pretty interesting vulnerability, which is called pawn request. This again works on workflows. To give a bit of context before we get into this, so there are like triggers, like what we saw earlier on issue. Similarly, there are some triggers in GitHub workflow that people very commonly use. One of that is pull request. Pull request is something when someone makes a code and then they want to commit and push it back to the repository, right? That is where the people create pull request. And when a pull request is created, this trigger is that particular action triggers this particular workflow. So again, there is another concept of forking repositories, where let's say there is a public repository somewhere, and you want to make a copy of it and work on it. People are allowed to do that. So here, this is something that we see, which is combined with a fork, plus when a trigger, something like this is used, something like pull request. Just to understand a bit on pull request, so this is how a very the common workflow looks like, where let's say on the left side that we can see there is a repo A. Let's assume that's a target repository, and let's say a user is trying to fork this. A fork of repo A is created. Let's assume that this user, once forked, they make some changes. They make they push the commit and they merge it. And let's say they create a PR in the original repo. So what happens once that is done? It goes to the original repo, that is repo A, that was initially created. That's a target repository. And looking at the workflow file that we have, this workflow triggers on a pull request. So as soon as this pull request is created, right, the execution starts on the original repo. So like we can see, this triggers, but with the trigger that is pull underscore request that we see here, it's a safe thing to use. Again, to keep in mind, with the right set of steps. Here, what happens, if we see, checkout is one of our action that we use, very common action that we use in GitHub, which basically, to put it in very simple terms, it downloads the code. So once this is done, basically, this runs in the context of the forked repository. So whatever changes is made, that is something that is accessed. And whenever this runs, there is no access to secret or write access to the repository in this case. And this is safe. There's nothing wrong happening. This is just a workflow that we can look at. But when it comes to this particular trigger, right, pull request target, so this is where things go a little wrong. So basically, what happens here is it's exactly very similar to what happened earlier. This was introduced by GitHub because of a lot of requests that they received, and basically what happens here is people, let's say someone forks it, they execute it, they create a PR to the original repo. But here is what it happens. So when the checkout is run, here it runs in the context of the target base repo. So here what happens is it has access to secret, it has access to write permission to the repository. So basically, let's say if the person who forked the repository has some malicious code, saved in that particular repository or the PR that is being pushed, it gets executed in the base environment. So that's where attacker is trying to target. The person can access their secrets, whatever is present in the original repository. Just moving on, this is one of the classic examples that we can see. This is something that we just saw. Maybe a quick thing about tokens. So there are few options that GitHub gives us out, where these are 4 different types that we can commonly see, and there are a few things that goes wrong where people use a lot of very unsafe way of creating a token that's, let's say, for example, with no expiry, a long expiry, with a lot of access and things like that. So there are like some safe options. For example, let's say GitHub token is something that GitHub provides. That's pretty safe to use because it has a very limited scope and short expiry. Maybe it helps. If it helps, you can take a screenshot of this. I'm just going to move ahead. Uh, I think we saw this checkout a little earlier. Like basically, it's a third-party action. Basically, it's again like dependency, we can say, in a way, where we are using someone else's code to execute in our environment. So this is very commonly used everywhere. Like almost every repo would have been using this. Yeah. So whenever we use third-party actions, it's basically again supply chain, right? So something wrong or something malicious present in that will affect us. So it's always good to make sure that we know what we are using. Again, like talking about secrets, repo can have a lot of secrets where you can save secret in a repository, and anyone who has right access to the secret will have access to all of these secrets. I mean, that is safe. Maybe if not directly, they can there are ways where people can use base64 and basically look at the secret, have a they can take a look at it. If that is something that we want to avoid, there's a safe option that GitHub gives, that is environment secret, which requires an approval workflow, and that is a safe option to use. Again, I'll let Arpit go ahead with this.
Uh, so yeah, basically, this is about self-hosted runners. So as we saw in the previous slides, when you combine all of the attacks from workflow injection and pawn request, and if you're using a self-hosted runner, and that impacts even more, and the risk of using a self-hosted runner is even greater when it comes to like public repositories, because what we showed in the previous slides, like exfiltrating secrets, getting inside access to your source code, all that can be done by a malicious hacker. Yeah, so misconceptions while choosing them is probably, like, you would have heard this from a lot of people. They're saying that it's safe on the marketplace, but is it really safe unless and until you've vetted it properly? I don't think so. And lack of due diligence, like I mentioned, like if you aren't going through the source code of your third-party apps and actions, it is still not technically secure. Yeah, I'll move on to GitHub apps. I think we're all familiar with this really famous GitHub app, third-party app, that is Slack. But if not many people actually focus on the details, right? So when a third-party app asks for permissions, it's usually read access to checks, code. So basically, it accesses your code. It has read and write access to your deployments. So this is another risk if you think about it. Yeah, and like I mentioned, review permissions. This is something that like every single developer, security engineer, like it should be from a top bottom approach to review permissions, because GitHub themselves give out a disclaimer saying that when you install an app, you grant permission to your whole source code. And these are some of the recent attacks and data breaches that happened with respect to supply chain attack and GitHub, insecure misconfigurations and so on. One of them was Mercedes-Benz and JetBrains that we saw recently. Yeah, like this is one of the takeaways that we wanted to talk about. So as you can see, the ones highlighted in blue are the your environment, that is your GitHub environment. That would include GitHub apps, GitHub actions, workflows, runners, misconfigurations, and yeah, these are some of your the ones in green is your remediation. I would request anyone to if you want, please take a screenshot. I mean, like a photo of this. This would be helpful. Yeah, I'll move on to the next. So where do people go wrong when it comes to third-party GitHub apps and actions? what we mentioned previously, people blindly trust in the third-party apps and actions. People think that it's like, it's okay to give complete access or to not review the app. And yeah, these are some of your best practices. But apart from this, I would like to reiterate again, read proper documentation for each and every third-party app and action. That would save you a lot of time and in case you're using a unvetted, unreliable third-party app or action. Yeah, that's about it. If you guys have any questions, feel free to.
Hello.
Yeah.
The execution environment for where this code is executing, right? Your ls command that the output is here.
Yeah.
This is a system that is owned by you, or this is on GitHub's runners?
Okay, so to answer that, again, it can be both, right?
It
So
can be both, yeah.
I mean, this is just an example. So if it is GitHub runner, it's again like, a temporary thing that runs.
Yeah.
That's bad, still better. But if it is your self-hosted runner, that's, pretty serious and risky because it might be from one of your infra, right? Like, let's say you might be using your AWS,
Yeah.
and that impacts, like the impact is huge there.
Got it. So I'm trying to understand who the threat actor here is.
Okay.
And once the exploit has executed, what is the threat actor getting that he or she did not have earlier access to?
Understood. So threat actor can be like someone who, let's assume the scenario where it's a public repo. The threat actor would be anyone who can raise a, issue, right? So anywhere like where, again, this is the classic input, trusted input flow, right? So here it's basically untrusted flow. So wherever, like, if you go back to one more slide, Arpit, so there are like a lot of, I think couple more. So there are a lot of, these things like, where these can be like, all your untrusted input where people can put their, or pass their inputs. So anywhere you're accepting these things, I think it should be like it should be the case where you review it and make sure that, there's no untrusted input that you accept.
Okay, thanks.
Thank you.
Thank you.
Thank you so much for your time. Thank you.